back to yet another video on our channel Euclid Mathematics. We have started lecture series on a ring theory as well other subject too, like linear algebra, group theory, complex analysis, all subject I have started. Within that, I explain some of the solved example from previous year question paper and also the detailed understanding of the topic. Already it is there in my playlist. So if you wanted to check this video, you may go through my playlist and check it. In my today's video, I will explain to you all one of the fresh topic which is from ring theory. So which is a Gaussian integer. Okay. So in my previous lecture, I explained to you all the definition of ring theory and its properties. So if you wanted to check these ones, you may go through my playlist. Okay. So now let's get started on today's topic, Gaussian integer. I will explain to you all how we can form the Gaussian integer. Here is the definition for Gaussian integer. Okay. The Gaussian integer, it says that when we have zi, Gaussian integer represented by zi, when we have element in the form of a plus bi, okay, a plus bi, and that a and b, it belongs to the integer. Okay, so a belongs to z, b belongs to z. Okay, so when we have such a type of the numbers, then we say that it is the Gaussian integer. Okay, so when we take in general z, okay, when we take integer and its order of that integer, okay, order of that Gaussian integer, it always infinity. Okay, because z is infinite group, that's why order of Gaussian integer, it is infinity. Why it is infinity? Because of that we can form n number of elements, infinite number of elements, by using the value for a and the value for b. Okay, so all are coming from the integer, so that's why the order of Gaussian integer, it is always infinity. Okay, so and one more thing is there, so Gaussian integer modulo I under addition and multiplication, it is a ring. Okay, already I explained how it is, why it is a ring. Okay, so it is already there in my playlist, you check these videos. So why Gaussian integer under addition and multiplication is a ring. Okay, now in my today's video we learn only how to form group of a Gaussian integer. Okay, now see, let's get start the Gaussian integer under modulo n, and then we'll form the group of a Gaussian integer. So Gaussian integer modulo n. So why modulo 1 n? Because we wanted to make that Gaussian integer at some finite number, like a finite number. Okay, then and only then it is possible to identify their numbers and to operate these numbers. Okay, so for this we have to make it a finite. So if we want it in a finite mode, so we have to apply modulo n. Okay, modulo n means after some certain stage these numbers are getting repeated. Okay, that's why modulo n. So we define that Gaussian integer modulo n over I, which is equal to a plus bi. A belongs to zn and b belongs to zn. Z is infinite, but zn is finite. Why? Because n is, our z is having some certain modulo n operation. Okay, so that's why Gaussian integer modulo n I, which is equal to a plus bi. A belongs to zn and b belongs to zn. And Gaussian integer modulo ni, it is not infinite group. Okay, because it is having at end element also there, and after that end element, the number of elements which coming after, it's getting repeated. Okay, so here order of modulo Gaussian integer modulo ni, which is a n square. Why n square? Because it involvement of two numbers is there. Okay, so a from zn, b from zn, that's why order of zni is a n square. So Gaussian integer modulo n. So if you wanted to find number of elements in a Gaussian integer modulo n, always find out that n square. Okay, like a modulus of z10i, that means you have to find out 10 square. Okay, so modulus of zni is a n square, which is the order of Gaussian integer modulo n. Now let's get start how we can construct Gaussian integer modulo ni. Okay, so we'll start from the n which is equal to 1, then we will move to n is equal to 2 and so on. Okay, now here construction of a z1i. Okay, construction of a z1i, that means how many elements are coming in z1. Okay, z1 means the element which coming in integer, okay, which does not involve 1, it is involvement of only 0 there. So z1, it contains z1 which contain only the element 0. Okay, so if we want z5, so the element which is starting from 1 to starting from 0 to end at 4. Okay, when we take modulo, that's why 0 is there. Okay, when we go to the 5 become 0 under z5. Okay, so this is the way to find out the element of a zn. Okay, so z1 contain only singleton element 0, so I written here already z1 is contain singleton element 0. Okay, so that means we have possibility for a plus bi, like a is a 0 and b is a 0. Okay, we do not have any other option or any other possibility to construct z1i, so that's why a is a 0 and b is a 0. So I consider a 0 and B0. So there we have only one element under Z1I, 0 plus 0I, A belongs to Z1, B belongs to Z1, that means 0 belongs to Z1 and 0 belongs to Z1. Okay. So order of Z1I, which is a 1 square, that means 1 square means 1. So we have only the single element in a Gaussian integer modulo 1I, which is a 0 only. Okay. So order of Z1I, which is 1 square, which is equal to 1. Now similarly, we have to apply for a Z2I. But now in this situation, under Z2, we have two elements. One 0 and second one is a 1. So now take the next operation for Z1I. So here it is the next operation, which is a Z2I. So we want the construction of a Z2I. That means we want the element from Z2I. So Z2 contain two elements, which is a 0 and 1. Okay, Z2 contain two elements, which is a 0 and 1. And we have to apply all these possibility for A and B. Okay, so if I consider A as a 0, then we may consider B as a 1 or B as a 0. If we consider A as a 1, then it is a two option for possibility for B, which is a 0 and 1. Okay, so apply this possibility here and let's construct the element from Z2I. Okay, so Z2I means A belongs to Z2, B belongs to Z2. So possibility for A, which is a 0, 1, and a possibility for B, which is also 0, 1. Now substitute it here. Z2I means A is a 0, then B is a 1. Okay, so if I consider A0, B0, okay, A0, B0, then what we will get? 0 plus 0I, that means 0. If I consider A0 or A B0 and A1, so if a B0, then A1, it will remain 1 plus 0I, that means only 1. Vice versa, if I consider as A0 and B1, then 0 plus 1I, it is only remaining 1I. Okay, and last remain possibility here, if A is a 1 and B is 1, so 1 plus 1I, that means 1 plus I. These all are the elements from the Z2I. Okay, so here I have written the possibility for AB 0, 0, 1, 0, 0, 1, 1, 1. So apply this possibility to our A plus BI, we will get the Z2I here. Okay, so similarly find out for Z, or now order of Z2I. Order of Z2I means 2 square, that means 2 square means n square, n square means 2 square, it is a 4. Okay, so order of Z2I is a 4. Now we can see we have 4 elements. That's why number of element in our group which represent the order of group. Okay, so how many elements? 4 elements. So order obviously it goes to 4. Now here in our group we have limited number of elements, so it doesn't seem like a big deal. But when we have n number of element or more than 100 element and more elements, so it is quite difficult to find out the their number of elements. So that's why these results are very much useful for finding their order. Okay, so now this is the construction of Z2I. Now let's move for the construction of a Z3I. Okay, so here in a Z3I we have again Z3 here, and under Z3 we have 0, 1, 2, 3 elements. Okay, so we have to apply 3 possibility for A plus BI. Okay, so A belongs to Z3, B belongs to Z3. Now if we consider, okay, so we have 3 options to consider for A, B and C. So for A, if I consider A0, B0, okay, we have only two A and B. We have to take the possibility from Z3. So A0, B0, A0, B1, A1, B0. Now find out all these possibilities here. Now make sure that we have Z3I, that means a 3 square. We want the total 9 number of elements. 9 number of elements means total 9 number of possibility we want it here. Now put all these possibility to our A plus BI, we'll get the Z3I. Okay, so if A0, B0, we'll get the A0 plus 0I 0. Then A0, B1, that means 0 plus 1I, it will be I only. So similarly apply for remaining element too. So you will get the elements from Z3I, and total number of elements, it is the order of Z3I, it is a 9. Okay, you may count this one, it is total number of 9 elements there. So order of Z3I is a 3 square, which is a 3 square become 9. Okay, so this is the construction of a Z3I. Similarly you may go for Z4I. Okay, so I have taken directly Z5I. Okay, so it is easier to construct Z5I. Okay, so for Z5I you have the number of element in a Z5, 0, 1, 2, 3, 4. Okay, so these are the element from Z5. So all are the element from Z5. Now select A and B, possibility for A and B. So total possibility from A and B from Z5. Okay, so Z5 means number of element in a Z5 is a 5 square, it become a 25. So we want the total number of a 25 possibility. Okay, so total 25 possibility, that means take the 25 possibility from Z5, substitute it here, we will get that required number of elements in a Z5I. Okay, So all are the possibility from Z5i. It is quite easier to find out. Similarly, as we did earlier, so we have to apply similar process here to get the value for Z5i. Okay, so order of Z5i means n square means 5 square, which become 25. Okay, so total number of element in a Z5i, it is a 25. Similarly, Z6i, Z7i, Z8i, and Zni we can construct by this way. Okay, so we have only two elements A and B, so we have to select a possibility from our Zni for A and B. Substitute this possibility to our A plus Bi, you will get the required number of elements. And to cross verify number of element, you have to take their proper standard result, like order of Zni is a n square. Okay, now verify by using order of Zni as a n square number of element. Okay, so this is all for our today's lecture. I just wanted to explain to you all how we can form a Gaussian integer modulo n. Okay, how can we form Zni? So this is the only for our today's lecture. I hope you all have understood my today's lecture. So if you wanted to go for detailed understanding, you may find Z7i as your homework. Okay, and if you found anything difficult, let me know in a comment section. I will upload similar video in my channel. Okay, so thank you everyone. Thank you for my today's lecture.